So, welcome to 23rd lecture, and we have been discussing about how to find out currents in time domain by solving your classical differential equations. Essentially, I am doing this, but applying this to solve a circuit the way I have learned. And last time I told you that RL circuit excited from a, in fact it could be any source, but sinusoidal source is one of the most popular excitation voltage, because you know our power system is 50 hertz and it is sinusoidally varying. Therefore, people often ask that what will be the response of current in a circuit, be it RL, RC, whatever it is, to find out the solution. Achha. Now, I will do the same thing, but not completely. I will leave it to you to do that. Suppose an RC circuit. Very quickly, let me do this, so that for completeness sake, it can be, you can proceed further. Suppose an RC circuit is there. I will switch on it to a sinusoidal voltage source. Okay. So, this is V t, and I will do it rather quickly. See, and the switch will be closed at t equal to 0, and let V t be is equal to V max V m, I was writing sin omega t. When I say I am doing this, so this is my supply voltage, which is sinusoidally varying, and I am telling I will close the switch at t equal to 0, means at this point when voltage is going to 0, through 0 and towards positive. This is the instant of switching, and this is V max. I want to find out not only current, but voltage across the plate of the capacitor. Suppose I want to know what is VCT, I want to find out. Which VCT? With this plus this minus, and I tell you the boundary condition is equal to 0. If you just allow me to do this, because otherwise I have to carry this one. This I will write as supply voltage Vs, and here I will simply write the voltage across the capacitor is not say Vt, like that. So, Vst is V max sin omega t, and this is given boundary condition, which it tells you that V 0 plus has to be also 0. Now, so the steps are once again same. I have to write down the KVL here, but recall that the way IT I have assumed. So, this IT is nothing but C dV dt. So, if I have to solve for V t, I have to write down a differential equation involving V t. I generally solve for V t first, then I t can be found out. If you have got the expression of capacitor voltage C into dV dt you do, you get I t. Otherwise, what happens if you want to write down the KVL equation, this is R I. KVL equation, this is also true, that is this drops here R I plus 1 by C integral I dt, this is the voltage drop here, will be equal to V s t, that is perfectly okay. But you see, this is not a differential equation, it is an integral sign is there. But whatever way we have learned is better form a differential equation, and that differential equation can be formed easily in terms of V t. What is the KVL? We have done this. In the root, it will be V s t minus 2 plus minus R I, that is minus R C dV dt I is this one, and minus v plus to minus back to this point, and this is equal to 0. Therefore, once this differential equation is written, I will go a bit faster, so that you understand what I am doing. So, this is V m sin omega t. This is the thing, this is the forcing function. Then which it is not necessary absolutely, but follow one method, first divide by R c, bring it to that form, and write it like this, V m by R c into sin of omega t. So, here is the differential equation with a forcing function. So, once again the characteristic equation I will write straight away, it is m plus 1 over R c is equal to 0. Therefore, characteristic root is minus 1 over R c. And then the solution, the form or nature of solution is very easy to write. It will be only a single root, no multiple root, a into e to the power minus 1 over R c into t, and plus solution due to forcing function. Solution due to forcing function, once again it is a sin omega t term. So, k 1 into sin omega t plus its higher order derivatives. So, the higher order derivatives will only yield sine and cosine terms. So, all sine terms you group together and write a big constant k 1 sin omega t, it has to be, plus k 2 cos omega t. Got the point? In the same way as I did in case of finding current in an RL circuit. So, this is the nature of solution, and I am telling you, if you have understood this expression, your only job left is k 1, k 2 and a. You have almost solved 70% of the problem the moment you write this from this. Nothing could be nicer than that. Okay, differential equation, this is the solution. You have to find out k 1, k 2 etc. How to find out k 1, k 2? Because the solution due to forcing function will satisfy the differential equation alone. So, use that one in the same way as I did it. So, put this solution to this differential equation and it will satisfy this one. So, it will be k 1 omega dv dt cos omega t plus 1 over R c is there into k 1 omega cos omega t, sorry, this will be this term we are still there, there is another differentiation you have to do, that will be equal to k 1 omega cos omega t minus k 2 omega sin omega t, is not dv dt, this part only I am putting, this will be there, plus 1 over R c into this one. So, 1 over R c k 1 by 1 over R c sin omega t plus k 2 by R c cos omega t. 4 terms will be there, and that will be equal to V m by R c sin omega t. Got the point? So, this is how I will get. Then the next step is, it is an identity, It has to be satisfied for all time t. Therefore, the coefficient of sin omega t and cosine omega t you equate. So, sin omega t terms are in the same way, exactly same way. This is sin term, this is sin term. So, you will get k 1 by R c minus omega k2, this is the coefficient of sin omega t from this side, it must be equal to V m by R c. This is equation 1, and similarly equate the coefficient of cosine omega t, which will be equal to omega k 1, this term, and plus k 2 by R c, k 2 by R c, and this has to be equal to 0, because there is no cosine terms. So, these two equations can be solved to give you the value of k 1 and k 2. Then put it here, put the boundary condition V 0 plus equal to 0 to determine this constant A. Okay? Got the point. And I leave this problem to you to solve for it, solve for V t, because it is exactly in the same line as we have done RL circuit. It will be a good exercise to try on your own and get the value of the voltage across the capacitor, and then do C dV dt to get the current waveform. So, you see that so there will be also capacitor voltage cannot change instantaneously, but there will be transient appearing in the capacitor voltage like that. You please complete this, complete this, because of same nature, complete. So, k 1 k 2, then what you have to do? Find out k 1 k 2, solve these two, then find, after this you have to find A from total solution, mind you, this is the thing. Okay. Now, what I will be doing? So, any circuit I can write like this and solve for the transient if it is sinusoidal. I told you the supply voltage, any differential equation, it will be after all a differential equation. Suppose you have a differential equation like this, dy dt plus A y is equal to x t. Depending upon the problem, if x t is voltage, write voltage here, y is current, and so on. So, coming back to this once again, any differential equation, or it could be in general a higher order differential equation, because if there are two energy storing elements plus A dy dt, second order, plus B y is equal to x t. Now, you see, we have done this for sinusoidal current, for DC voltage, we have done that. Now, what I am planning to do is this, another interesting way to handle the previous thing. Earlier it was like that, when we did not know, okay, differential equation, then you integrate it by an integrating factor, try to solve them, that was a huge task, is not? Then we improved upon it. I told you that solution of a differential equation consists of two parts. One is the natural solution, depends upon the characteristic root, and exponential terms will be there, and there is another solution which depends on forcing function, which can be written straight away as k 1 x plus k 2 x dot plus k 3 x double dot and so on. And that way, applying that only, I solve this RL and RC circuit. Now, for a class of x t, the labor can be further reduced. That is what I am going to tell you how. If x t happens to be this point you try to understand, happens to be an exponential function then the solution due to forcing function can be obtained rather easily. What is this statement says? Suppose you have a solution, let us take a second order system d2y dt2 plus a dy dt plus by. See, solution due to natural response will be depending upon the characteristic roots. Okay. Now, what I am telling, if x t is the form as some say e to the power s t, it can have some magnitude also, say p into e to the power s t. On the right hand side, it is a exponential function, and this I will just change a bit. If x t happens to be an exponential or DC constant, because with s equal to 0 this will appear to be a constant, p is constant. Suppose we have excited a system with this signal, okay, and want to solve for y. Then how to find out the solution in this fashion? Let us see. See, if this is the solution, this is the function, first I say that this is constant, I mean exponential term. We argue like this, okay, this is very interesting way to look at the problem. The left hand side, and we are looking for the response due to forcing function only, this you must understand, forcing function only, because other terms will be there, a into e to the power m1 t plus a2 into e to the power m2 t, that thing will be there. So, forcing function is this is your forcing function. Now, you see, look at the left hand side and the right hand side, and forcing function alone will satisfy the differential equation, and I am looking for the solution. Now, the question is, what should be the nature of this solution? If the right hand side is exponential e to the power s t, see e to the power s t, and for all time whatever will be the nature of y t, for all time left hand side if you compute, it has to match the right hand side. That is a crucial point. Therefore, the question is, can I guess what should be the nature of y t? The answer to this question is that yes, you have to look for such a function y whose form does not change when you differentiate it. Then only these three terms will conspire and will always give you this term. That is the nature of the solution of this side guessing. It has to be also exponential e to the power s t. Then only if you differentiate it twice, it still remains e to the power s t into some constant. dy dt you do e to the power s t into some other constant plus by e to the power s t. Yes, all these e to the power s t terms may add up and give you 0 for all the time t. It cannot be one term is t square, another is t cube and things like that, which will add up to 0 for all time t. Mind you, solution means for all time t. Therefore, we guessing the solution to be this very interesting point. I will guess the solution will be some q into e to the power s t. It has to be, nothing doing, p e to the power s t. So, left hand side will also give rise to a factor e to the power s t, and exponential function is such a nice function. Differentiate 100 times, it will still retain its form, only thing its magnitude will get manipulated, amplified or decreased, that is different issue, but only this form of solution can satisfy the forcing function solution straight. So, what I do, I put this solution here on the left hand side. So, you know dy dt, I have to calculate dy dt because I have to put it here. So, dy dt will be how much if you assume this to be solution, s into q into e to the power s t, is not, and d2y dt2 also I will require. If you differentiate it once more, it will be a square q e to the power s t, is not. Then I put it here on the left hand side, put this on the left hand side. What you will get? You will get a square q into e to the power s t, that is the first term, plus a times dy dt, which is s q e to the power s t, plus b times y, which is equal to q e to the power s t. And on the right hand side, I have got p into e to the power s t, is not. This is the thing. This is the equation I will get. Now, on the left hand side, what I will do, I am going to do this thing. I will take q into e to the power s t, which is common to all the terms, and inside I will get a square, this one, plus a s and plus a b, and right hand side is p to the power s t. This is the input forcing function, input forcing function. Therefore, I will say, because I want to, I have guessed the nature of the solution, but still q is to be determined. This solution is totally not known. So, I will say S is known, mind you, from the input excitation. So, I will say q into e to the power s t is nothing but p into e to the power s t divided by a square plus a s plus b, is not. Therefore, you see, if the right hand side happens to be a exponential function of the form e to the power s t, and this is the solution, because this is the solution q e to the power s t, then becomes the input exponential. In language, if I write input exponential divided by what? What is the characteristic equation of this one? Of this differential equation, characteristic equation is how much? M square plus A m plus b. This is the characteristic equation, is not? Or you can say in terms of differential equation, you think in your own way, a d plus b into y is equal to q into e to the power s t, q into e to the power s t, is not? This differential equation in short can be written like this: d square, d is the operator, plus a d plus b into y. So, it looks like that y t solution due to forcing function will be this one we have got. From this equation, I will say, oh, it is q e to the power s t divided by d square plus a d plus b, as if some algebraic thing. Okay, y is this divided by this, I bring it, but this is not correct to write the operator in this way. It is difficult to manipulate, but the result is this: characteristic equation coefficients come, and I will say, oh, this is d equal to s. So, the solution due to forcing function, when it can be expressed in the form of an exponential, the solution will be simply that input divided by this characteristic equation evaluated at d equal to s. So, to summarize what I am trying to tell in the next thing I will tell, that if you have got a differential equation d 2 y dt 2 plus a dy dt plus b y is equal to, suppose, some q into e to the power q or p I dot p. So, this is p. What was the solution I was telling earlier? Solution will be from our earlier thing, total solution will be a into e to the power m 1 t, that natural response will be there, b into e to the power m 2 t, plus then we learned it should be like this. This, if you say x t, it will be k 1 x plus k 2 x dot and so blah 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 up to infinity, like that. But I am now telling something new, that is fine, but we found out from the last slide what is this m 1 m 2. M 1 m 2 is the root of this characteristic equation a m plus b equal to 0. Roots are m 1 m 2. So, this natural response will be there, whether there is a some consolation we get to calculate the solution due to forcing function. Yes, it is. Now, I am, after learning that, I will say total solution will be this: a into e to the power m 1 t plus b into e to the power m to t if the roots are distinct like that, plus what I am telling, if the right hand side is of this special form, I will say it will be simply p into e to the power st solution due to forcing function input divided by the characteristic equation, that is m square plus a m plus b, but put for m s, that is equal to a into e to the power m 1 t plus b into e to the power m 2 t plus of p into e to the power s t by s square, but for m put s this coefficient, s square plus a s plus p, and you are ready with the solution. Got the point? Determination of constant, those things now become that k1, k2 finding out was slightly difficult. What happens if excitation is DC, is constant? Say right hand, that is right hand side is p is equal to constant. Anyway, this can be written as p into e to the power 0 t. So, the solution then will be a into e to the power m 1 t plus b into e to the power m 2 t plus p into e to the power 0 t, that is p, divided by s equal to 0, that is s square plus s plus b, s equal to 0, that is it will be equal to a into e to the power m 1 t plus b into e to the power m 2 t plus p by b. If the right hand side is constant, then the solution due to forcing function will be simply suppress these two terms p by b. Anyway, we will continue with this in the next class as well. Thank you.